go. Okay, we are going live. Yes, there we go. We're going to be live. It's taking 2 more minutes. Hmm. So, okay. Yep, that's going. We'll start on the dot. Hmm. Yes, hello, Char. Hello, hello. Yes. Give it 1 more minute. Let's start on the dot. All right, it is 4:30 p.m. Eastern Time here. Hello, everyone. Yes, happy Guy Fawkes night, or happy Guy Fawkes Day for those who celebrate. Yes, remember, the 5th of November, and here we are. So, today we're going to. Originally, I was going to have nothing planned out today, but I have some really good demos and examples to show today. So far, over the last, oh God, it's been like 7, 8 weeks already we've done this. We even had a guest speaker last week. We've talked about vulnerabilities. We've talked about, we've covered web security, SQL injection, cross-site scripting. Again, I said I think it was during the first couple of weeks, I remember saying, there's a reason why I do a certain order for my introduction to security class. So a couple weeks ago we did vulnerabilities. A couple weeks ago we did web security. Today, because my security class are finishing up the capture the flag game and also password cracking competition, in which I will announce the answers. I will finally reveal the answers tomorrow for the password cracking contest that's been going on for over a month. I'm going to try to make today short. Probably today, hopefully, I'm going to do maybe like 30 minutes. And the whole point of today is going to be looking at some really bad code. Again, we're going to look at some really bad source code, vulnerable source code today. And I got 3 good examples to show. This ties in extremely well with everything that we've covered so far, especially when it comes to vulnerabilities, web security, and CWEs. So, let me open up the first example of really bad code. And the first example of really bad code, I think that was going to tie in really well with the last few weeks, especially when it comes to web security. And let's start with Java. Okay, here you go. Alright, so Liger wants to show his code. I think this is close enough. Here we go. So this is really bad code number 1. Hopefully I can enlarge that. This is written in Java. Tell me everything that's wrong with it. So I'm going to stay silent for a few moments I'm not going to talk about it, but I want you to take a look at this example. This is Java code. Mm. Point out all the issues. Point out all the vulnerabilities. Mm. I'll let you have folks, and feel free to chime in on chat. I am looking at the chat on Twitch. Mm-hmm. Yeah, okay. Keep coming. Mm-hmm. Keep them coming. Keep them coming. Mm-hmm. I get this every year, like every semester. It's like, how does security tie in with programming and programming languages? Well, here we are. Okay. The vulnerable Java code. Hard to see, but either. Okay, hold on. Is this a little bit bigger? No, enlarge the font. Maybe this would help. Well, that's a whole load. Is that a little bit bigger? That better? We got Twitter content isn't clean. But yes, this is actually a working program. This is actually a working program. And there is an assumption that it is actually reading Twitter data, which there is. Assume that there is data from Twitter in the database. Yeah, go ahead. Hey, Topher. Been a while. Yeah, absolutely. Anyone can chime in. Anyone can chime in. Anyone can chime in. This is a little bit bigger. I think this is. I remembered. I think it was B-sides. When I first B-side Las Vegas, when I saw the Amazon recruiters, they were showing up. They were showing really vulnerable code examples, and they were conducting like technical interviews on the spot. And yeah, they just showed a whole bunch of source. Could keep on executing forever. Well, yeah, you can have that. What else do we got? Hard to see, but either unclose or multiple closed statements. Heh. Actually, it's even better. Yeah. Yeah, since the argument. Yeah. Okay. So can I actually move the mouse? Can I scroll? Nope. Just don't need to scroll. Actually, there's one like T. Let's see if I can. There you go. All right, that's good. That's good. Here we go. Okay, let's talk about this. Let's talk about this Java example. And there's a number of issues here, and as everyone point, I mean, I'm just looking at the chat. Juicy hard coded credentials. Yes. You have juicy hard coded credentials. Uh huh. You have juicy hard coded credentials. You have your username is root. You have a you have your password that Ronaldo Pinaldo is better than Messi. Well, we got some friends who are diehard Messi fans, so I think this draws their ire. So yeah, juicy hard coded credentials is definitely the thing that you should that should just stand out. I mean, you gotta find you gotta know you gotta identify that one is just glaring. I mean, that's on a 1 to 5 alarm system. This is like a 5.5, 6 alarm fire. To have your username and password hard coded. So how does this tie in? So how does this tie in? Hard coded credentials here. Let's take a review. The 2020 CWE Top 25 Most Dangerous Software Weaknesses. Where does that fit? Right there. CWE 798 use of hard coded credentials. So that's one. That's one of the big ones. Yeah, I mean, I just use Pinaldo because, nickname. I'll just leave it at that. Let's not get too deep into that one. Well, there's also another big problem is the username is root. I mean, when you have a username as root is super user, administrator, can do whatever, root can do anything. So that's another issue is way over privilege. And so this is also what they call a principal of least privilege problem. You never want to connect to a system, in this case a database, as root. Okay? So that's one. Now that's another issue. Uh, Most of you realized, I'm looking at the chat log right now, the other glaring issue is, as Topher said, least privilege, yes, yes, yes. Um, the injectable issue with the argument. So, I guess you can actually say a couple of things. Well, arg0, the argument, that's injectable. And ultimately, line number 13, where you have a SQL query and you're just doing string concatenation, you're looking at SQL injection right there. Right there. You have SQL injection on line number 13. And where's that actually on the CWE 2020 top 25? That's number 6. Improper neutralization of special elements used in a SQL command, SQL injection. That's 2. So the two biggest ones are, hard-coded credentials, 5 alarm fire, 6 alarm fire if you want to go, and SQL injection, not sanitizing args, user input. That's another 6 alarm fire. Those are the two serious vulnerabilities. There's also a lot of little ones as well too. Code quality. Line number 1, import java.sql.star. You're importing everything from the Java SQL package. You're importing everything. So in terms of code quality, why don't you just import the stuff you really, really need? Okay. Like I mentioned something about database like not being closed. Well, yeah, I didn't close the database at all. So I had to do a data connection con equals get the database connection, create the statement, but there's nowhere that I closed the database as well too. So having done Java web app, long time ago for 10 years, if you don't close the database connection, you're going to run into leaks. And I remember back in the days, I was writing code where I forgot to turn the database off. I forgot to turn off the database connection. And when there were n number of people using the web app, it was just opening way too many connections. And all of a sudden, one day, you would hear one person, trying to use the app, but there was an app, the app was throwing an error because, the database connection was not being closed correctly. So nowhere in the source code is the database connection being closed at all. Okay? Yeah, use JPA instead of manual. Yeah, that's definitely the one way to solve it. So, if you want to talk about defenses, like how to improve this code, you want to talk about verbally, let's talk about the biggest items is don't hard code credentials. Don't hard code them by storing them in variable. Username and password should not be in the Java source code. It should be stored in memory, or like commonly using like environment variables. You know, don't ever store username and password in within the source code like here. Just reference the username and password to a system, either in memory or better, or in environment variables. It's a SQL injection problem. Yeah, don't do string concatenation. I mean, certainly make sure that you sanitize the user input, but use the Java prepared statement library. This is a prepared statement library, um, that you can just do prepared statements, not the string concatenation stuff. Um, the least privilege issue in this case, as you can allude to, line number 9, it says com.mysql. Yes, we're using MySQL as the database. Create a separate user for this Twitter database. Don't connect as root. And another thing is, make sure you close your database connection. So those are the defenses against, this vulnerable piece of source. How you fix this vulnerable piece of source code. Okay, so this ties in really, really well with the last few weeks of content. Okay, so this is an example of vulnerable Java source code. Do another one. What about the programming language where you can get into some real trouble? Let's talk about C. All right, here's C code. Let's talk about C code. The C programming language. Yes. Take a look. What's the problem here? Give me a few minutes. Talk it through. Talk it through. Feel free to chime in on chat. This one I can demonstrate. And I'm sure showing this example will make people like Gary McGraw really, really, really happy. All right, I see a buffer overflow potential. How so? Where? Where is the buffer overflow potential? Yep. Mm-hmm. Mm-hmm. Okay, I'm going to just show the entire thing now. It's only 21 lines of C. Yep. Can you see? Yep. Mm-hmm. 21 lines. Overflow or underflow potential. All right. So I saw overflow, underflow. I saw Sterling. Does Sterling use it? Mm-hmm. All right, let's do this out. Why are you letting the user know what's in the memory and having it? Okay, what exactly a buffer overflow, underflow? Let's do it out. Are you ready? Okay, so let me. Things I can do. I'll pull up something called a terminal here. think I'm going to change this to... maybe I don't need to see it. Can you see it a little bit? Now I'm going to compile vuln.c. I'm going to call this executable program called fun. Ready? Compiled using GCC. Worked. Worked. Got a fun executable here. Let's just run the executable that we just compiled. No arguments. Well, that's one problem right there. Because we didn't specify any arguments after the executable. But let's now send an input of an A, lowercase a, into the executable, and here we go. Copying 1 byte into buffer 2. Buffer 2 now contains an A. Yeah, I didn't quite, yeah, I screwed that one up too. Alright, let's clear the screen. Let's do this executable again, but this time just do A as the input. So you want to know what a buffer overflow is? Watch what happens. Does anyone remember what the buffer size was? I think it was 8. Yeah. Let's do AA. 3 A's. Okay, that makes sense. Let's do 4 A's for your input. Alright, so far so good, it's running. Let's do 5 A's. So far so good, nothing wrong. Alright, let's add 1, 2, 3, 4, 5, 6, 7, 8 A's. Let's see what happens. Uh-oh. 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 Let's have a whole bunch of A's. Uh-oh. Uh-oh. Now we're getting some real screwy results here. Did you notice when we had a legitimate number of A's that was under 8, let's say 6? Take a look carefully. Copying 6 bytes into buffer 2. Okay, buffer 2 looks good, buffer 1 still looks good, and some buffer value is still 5. Okay, so that's still legit, still looking good, but if I go way over 8 bytes, I'm just going to go a run of A's. Guess what happens? Boom. This is what you call an overflow. All the remaining values actually get, because buffer 2 and buffer 1 were allocated to have, take a look at the source code. Size of 8. But the input is way over 8 bytes. It's trying to copy copying 25 bytes into buffer 2. Buffer 2 now, well, has some stuff, but also the content also gets spilled over into the other segments of memory, which are buffer 1 and also value. And you also know that the value is no longer 5, it is 0x in hexadecimal, 0x616161. Does anyone know why it is 616161616161616161? Can you do this with arbitrary code execution? The value hexes that keep on changing. Yeah, I mean, I can. My buffer overflow skills are a little bit weak here, but does anyone know why it's 61? Oh, yep, 61 is the ASCII character of lowercase letter a. Okay, so this source code here, all 21 lines, is a classic example of a buffer overflow. What in the world is a buffer overflow? Well, you go back to the CWE, top 25 most dangerous software weaknesses. Where is that located? Bing! CWE 119, improper restriction of operation within the bounds of a memory buffer. Okay, let's go and take a look at what CWE 119 is. Bam. The software performs operation on a memory buffer, but it can read and read from and or write to a memory location that is outside of the intended boundaries of the buffer. Okay, certain languages, see, allow direct accessing of memory locations and do not automatically ensure that these locations are valid for the memory buffer that is being referenced. This can cause read or write operation to be performed on memory locations that may be executed and be associated with other variable data structures or internal program data, which we just messed with in that example. The alternative term, buffer overflow. Okay, interesting. Yada, yada, yada. Okay, but the real culprit, if you go back to this, go back to the C program, a real big culprit is stir copy. It's a C function called stir copy, strcpy, also known as string copy. Okay, and the crux of the matter is there is a number of what you call the dirtiest of the dirty C functions, like stir copy, that does not do any bounds checking at all. Okay? Stir copy, strcpy, is one of these dirtiest of the dirty C functions you should always, I'm sorry, let me repeat that again. Stir copy, strcpy, is one of those dirtiest of the dirty C functions you shall always try to avoid. And there is a nice page. It's a common vulnerabilities guide for C programmers. Most vulnerabilities in C are related to buffer overflows and string manipulation. In most cases, this would result in a segmentation fault, but specifically crafted malicious input values adapted to the architecture of the environment could yield arbitrary code execution. You can find below a list of the most common errors and suggested fix and solution. Gets is one of those dirtiest of the dirty. And aha, here we go. Stir copy, strcpy built-in function does not check buffer length and may very well overwrite memory zone contiguous to the intended destination. In fact, the whole family of functions is similarly variable. Stir copy, stircat, stircomp. Okay, here's a vulnerable code. Okay. The best way to mitigate this issue is to use Sterling, STRLCPY, if it is readily available which is the only case on BSD system. However, it is very simple to define it yourself as shown below. There is a version of Sterlen copy, this is it is. So the biggest difference with Sterling, STRLCPY, is there has to be a bounds number required. Okay, so it's never going to go out of bound. This is one of the beautiful things of Java. It is, there's that bounds checking is built in. Slightly, although another maybe less convenient way is to use stern n. Same idea with the n. Stern copy, which prevents buffer overflow but does not guarantee null termination. Okay, so yes, as printf does not check buffer boundaries. Printf and friends does also have format string issues. Okay, file opening. These are some of the dirtiest C function, like printf, gets, stir copy. Some of the dirtiest functions you should never ever use. Use the equivalent that has bounds checking into them. Yes, you can send me a link. Thank you. Great. So, this is a deliberately vulnerable example in C that illustrates, well, buffer overflow, buffer overrun, going way out of bounds, no bounds checking, whatever you want to call it these days. For your interest, so I don't want to be accused of plagiarism, this source code, this example I use all the time to illustrate vulnerabilities in programming languages such as C, namely in this case, like stir copy, and it is just one of the dirtiest C functions that you should never ever use. I got the source code example from Hacking the Outer Exploitation by John Erickson, second edition by North Press. Great book. I went through it 10 years ago. This book is fantastic. Fantastic with lots of technical examples. Really amazing book. Highly, highly, highly recommended. Okay, so I'll do one more example. So we've done a vulnerable Java example. We've done a vulnerable C example. And now we will do, because I know a lot of young people like JavaScript these days, so we'll do a vulnerable JavaScript example. And this is server-side JavaScript. Vulnerable JavaScript. This is written, server-side JavaScript requires Node.js. Now, what's the problem? There is a very, very, very vulnerable, very ugly vulnerability in this source code, in this JavaScript example. I could use HTTPS, but I'm going to run this locally. So what is the vulnerability here? There should be one thing that should actually catch your attention right away. And this is just evil. I can actually run this example. This is a working vulnerable server written in JavaScript and Node.js. Here is the trick. Here is the thing. See, if I run this web server, which it is, because you can see it requires HTTP, see if you can shut down the server. That is what we're going to do. So I'm going to run this server. And let's see if we can shut it down. For this, I'm going to open up a new terminal. Okay. So now I am going to do node bone.js. The server's on. Server's up and running. So I am running this node deliberately vulnerable JavaScript deliberately vulnerable server on a box on my home network called Kali. So you know that the request method is looking for HTTP post. Okay? If you send it any data, it's going to do a console.log. It's going to print it out on here, and an end. Okay, wait. Here it is. Line number 17 is going to listen at port 3000. All right, and the server is on. All right, looks good. So I'm going to open a separate terminal. I'm going to exit out of here. I'm going to close this. I'm going to do curl minus data liger. I'm going to send some data, whatever it is. We can send anything to HTTP Kali port 3000. Let's see what happens. Got some data and end. Okay. Hit Control C on my terminal on my Mac. So I'm going to add a foo bar. Okay. Got some data, foo, colon, bar, and end. Okay. Let's do 1 plus 1. See what happens. Got some data, 1 plus 1, and end. Okay. Go see. Now, what happened if we actually send to the server functions, including JavaScript code? Interesting. Request.method. What if we did that? This gets interesting. All right, let's have some fun. What happened if I instead actually just said console.log request? Console.log is a legit function in JavaScript. Uh-oh. 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 Here we go. It's not only just spitting out just a tag, but it just spit out an entire object here. How about response? Look at that. The request and response objects in Node.js for this server. Being spit out. All right. What happened if I send, I think there is a way to run a process in JavaScript. What if I did process.exit 0? Do that. See what happens if I try to send this to the server now. Boom. No longer can connect. Blammo. Boom. Server quit. Got some data, process.exit 0. So here is the issue. Line number 6, I sent process.exit 0. So it's going to print out chunk is going to be the string that I sent to the server. Chunk is a string that I sent to the server. In this case, it's process.exit and then inside paren 0. And then I just print it out. But the issue is line number 12. Don't ask why, but, well, actually, the only reason why is to show line number 12. Then, line number 12, there is a function called to eval, which will evaluate the string that I sent to the server, in this case, process.exit 0. And so it's going to, what eval does, it's going to execute the string as code. That's what eval does. Eval executes string as code. Take a look. Now, okay, let's use W3 schools. Evaluates, what eval does is evaluate, execute Java's code expressions. Okay, the eval function evaluates or executes as an argument. Okay, if the argument is an expression, eval will evaluate the expression. If the argument is one or more JavaScript statements, eval executes the statements. Okay, many programming languages have an eval function. Okay, and of course, in the Mozilla Developer Network, they even have a big red warning on here that says, warning, executing JavaScript from a string is an enormous security risk. Okay? It is far too easy for a bad actor to run arbitrary code when you use eval. See, never use eval below. And that's the whole point. The whole point of this of this source code is eval is evil. That's it. Like, just don't ever use eval. Eval is evil. There you go. Why would someone want to do that on their website? I do know a legit case of eval is one legitimate use of eval I've ever seen is taking a string in JavaScript and parsing it into JSON. Like the Doug Crockford JSON parser, if I'm not mistaken, uses eval to take a string, like a JSON string, and break it down into JavaScript objects. That's like the only one good use of eval. So let's say you never use eval. Eval is a dangerous function which executes a code that is based on the privileges of the caller. If you run eval with a string that could be affected by a malicious third party, you may end up running malicious code on a user machine with the permissions of your web page extension. More importantly, a third party code can see the scope in which eval was invoked, which could possibly do the function. Okay. Here's the documentation. Basically, the point I'm trying to tell you is eval is evil. This goes for any version of eval in any programming language. JSON.parse, yes. Yes, JSON.parse is what we use. I believe behind the scene it does, if I'm not mistaken, it uses eval. But yeah, JSON.parse. If you want to evaluate, if you want to just parse JSON, yeah, just do JSON.parse. But I think behind the scene it uses eval, but use JSON.parse. Don't write your own or roll your own or reinvent the wheel JSON parser with eval. Oh. Alright? Eval is evil in any programming language. Hold on. Evil. When is JavaScript eval not evil? Here we go. On Stack Overflow, I'm writing some JavaScript code to parse user entered function. I just want to say this again, is that many programming languages have an eval function. That also include UPHP. However, I shied away from using eval because if I can avoid it because it's evil. The premise of it is evil. Okay. There are many code injection performance. Eval is faster than manual interpretation, or make it then you should. That's simple, okay. When you can trust the source. In the case of JSON, yep. Still use JSON.parse as much as you can, which I just built into JavaScript anyway. As long as the JSON itself contains no data a user has up, yeah, good luck with that. There's no major drawback in using val. Again, good luck with that one. Okay, so yeah, it really boils down to please don't use eval. Okay, so that is all I got for today. Thank you for tuning in. And we're going to end tonight early. Yes. Have a good night. Wait, before I go, do I forget anything? No, not really. I got everything tonight. Yep, I did everything. We covered bad code. We went to CVE, tied it in with CVE. Oh yes, one note that I do have. What do I do here? Go back to the original, my window, quit, clear. I posted the C and the vulnerable server JavaScript are in my GitHub gist. The Java example I use for examination or for interviewing purposes with people. Thank you, everyone. Have a good night.